Hello everyone, I'm Shrouk Gharib, PhD student in Concordia University working under the supervision of Professor Osama Moselhi, and I'll be presenting today a review of computer vision based techniques for construction progress monitoring. This is the presentation agenda. Construction progress monitoring is a crucial aspect of construction projects, playing a key role in ensuring process control and overall project success. In fact, inaccuracies in construction progress monitoring have been found to result in cost overruns in more than 66% of projects and schedule delays in over 53%. In recent years, computer vision has attracted significant interest from researchers due to its potential applications in diverse fields such as site safety, progress monitoring, and quality management. Along these developments, significant advancements have been made in the use of computer vision technologies like laser scanning, photogrammetry, and videogrammetry in the construction progress monitoring field. Consequently, there has been extensive research focused on data acquisition and construction site monitoring using various forms of media. In this research, we adopted a systematic literature review approach using the following databases and search engines: Google Scholar, Scopus, and Web of Science. The keywords used in the study included automated project monitoring, construction project updating, construction progress tracking, alongside with image processing, computer vision, 3D scene reconstruction, and building information and modeling. We reviewed and filtered papers focusing only on those relevant to our study from peer-reviewed conference proceedings, journal papers, and review papers. Further filtration was conducted to include only English language papers published between 2013 and 2022. After the screening and filtration, we selected and reviewed 156 papers. These papers were then categorized according to the year of publication and classified as journal technical papers, review papers, or conference technical papers. Based on literature review, the process of monitoring construction progress using computer vision in any construction site can be divided into three main steps. Data acquisition is the first and most important step in the computer vision construction progress monitoring process. The method used will determine how well the construction site can be monitored and how subsequent steps can be developed. The architecture, engineering, and construction industry leverages various imaging devices to acquire data, such as monocular/binocular cameras, unmanned aerial vehicles with cameras or video cameras alone, laser scanner, depth cameras, and others. For this, we identified the key performance indices for each of the technologies, what are the possible mounting methodologies, the extracted data type, the cost, the technical threshold, and their resolution. Now, for the second step, after the data acquisition step, the next step is to process 3D reconstruction algorithms to generate the point cloud model. Each technology has a different type of output that needs specific steps to follow. For instance, laser scanner output already generates point cloud model and does not require further processing. Also, depth cameras, they generate depth images which contains 3D coordinate information along with color information. This information is used for mapping and executing 3D reconstruction. However, digital cameras and video cameras, they produce images and frames that does not include any location information. Accordingly, structure from motion approach is used to add depth information for sparse 3D reconstruction. In this research, the basic concept of structure from motion as a technique for photogrammetric 3D for multiple image frames was introduced. Structure from motion combines algorithms for feature extraction, feature matching, camera motion estimation, sparse 3D reconstruction, and model parameter correction. These inputs for structure from motion are in the form of image and video data with recommended 60% side overlap and 80% forward overlap between images and video frames to achieve high quality and detailed 3D models point cloud as output. The next step after feature point cloud collection and camera position estimation is absolute scale recovery and dense 3D reconstruction. This is necessary because the output from this initial step is sparse and non-scalar point cloud that require absolute scale recovery and dense 3D reconstruction. The dense 3D reconstruction involves recovering the actual scene with all its details. On the other hand, the reconstruction output from the depth camera is dense enough and does not require the dense 3D reconstruction. To assess the current status of progress, determine whether it's behind schedule, ahead of schedule, or on track, and potentially take corrective actions, it's necessary to go to the third step, which is to compare the as-built model data obtained from the previous step with the as-planned data. The as-planned models are also called 4D models, which are 3D models with the project time schedule. Are the baseline plans for a project typically created during the design phase. As-built models are then overlaid on the 4D BIM to facilitate comparison between the models. Now, for the conclusion, here we achieved automated progress monitoring steps and introduced the research on computer vision techniques. We have done a systematic review of articles focusing on applications of laser scanning, photogrammetry, videogrammetry. The process for creating a 3D as-built model, which is a critical component of automated progress monitoring, was introduced, and at the end a description of algorithm used for estimating progress based on the data collected. For future work, improve algorithm in terms of accuracy and speed for generating the point clouds and 3D reconstruction purposes, and integrating image technology with other technologies such as for positioning, ultra-wideband, RFIDs, and GPS, and for data fusion models to integrate volumetric data with positions. Thank you so much. For any questions you have, you can contact me on this email or via LinkedIn. You can scan the QR code to link to my page. Thank you.